Okay, so in the last video we learned two new equations. We learned delta D is equal to VI delta T plus 1/2 A delta T squared. And we learned VF squared equals VI squared plus 2A delta D. So in this video we're going to use them so you can get a feel for how to use them. So in the back side of the sheet that I gave you the other day, there are three examples. Okay, so just up here I'm going to write what are the equations we can now use. So delta D is equal to VI delta T plus 1/2 A delta T squared. And every time you write it down, I want you to say it out loud because that'll cement it in your memory, okay? And VF squared is equal to VI squared plus 2A delta D. And just because we've learned these two new ones doesn't mean the other two that we had aren't valid. So we also then still have VAB is equal to delta D over delta T. And A is equal to VF minus VI over delta T. So there will be occasions when we'll use our two simpler ones. All right, example number 1. An airplane is flying 80 meters per second with an acceleration of 2 meters per second squared. What is the distance traveled in 10 seconds and what is the plane's final velocity? So remember the steps. Step 1 is write down your givens. So it's flying 80 meters per second initially. So that's our VI. So VI is equal to 80 meters per second. It says it has an acceleration of 2 meters per second squared. So our A is 2 meters per second squared. What distance does it travel in 10 seconds? So our delta T is 10 seconds. And we're looking for our delta D and the final velocity, VF. Okay, so delta D first. I have a VI, an A, and a delta T, and I want a delta D. So I go up here and I look at my four equations and I say, which equation do I have that has a VI, an A, and a delta T in it, and a delta D? And when I look at all four, I see, oh, it's the very first one. So I write it down. Delta D is equal to VI delta T plus 1/2 A delta T squared. And look how nice I was in the first example. I don't even have to rearrange it. So I'm looking for delta D, so I can just fill my numbers in. VI was 80 meters per second. Delta T is 10 seconds. Plus 1/2. 2 meters per second squared. 10 seconds squared. So 80 times 10 is 800. Meters per second times seconds is meters, plus. Now the squared here is only on the 10, so 10 squared is 100, and 1/2 of 2 is 1, and 100 times 1 is 100. Meters per second squared, and then it's going to be times seconds squared, because the seconds there is inside the bracket. So this will just be meters. So for the first part, I will get 900 meters for my distance. Okay? The second question wants to know in here, what is the final velocity? So what equation do I have that has a VI, an A, a delta T, and now a delta D too, and I need a VF? So you could actually use our one from grade 10 and from the first half of the unit, A equals VF minus VI over delta T, but we haven't used our second new one yet, so let's use it. So it'll be VF squared is equal to VI squared plus 2A delta D. And again, I don't have to rearrange because I'm looking for VF. VI, they told us, was 80 meters per second, and that's squared, plus 2 times 2 meters per second squared, and my delta D was 900 meters that we just found. So VF squared is 80 squared will be 6,400 meters squared per second squared. 2 times 2 is 4, and 4 times 9 is 36 with 2 zeros. And the units will be meters times meters, so meters squared over second squared. And now I add them together and I get VF squared equals 1,0,0,0,0. Meters squared per second squared, I take the square root of both sides and I find out that the final velocity is 100 meters per second. Okay? So steps, read the question, write down the givens, figure out what equation to use, rearrange it if you need to, fill in the numbers with units, solve. So let's look at number 2. A plane increases its speed uniformly from rest. From rest means VI is 0. Uniformly from rest until it reaches a speed of 50 meters per second. VF then is 50 meters per second. In 10 seconds, delta t is 10 seconds. What is the object's acceleration and what is the distance the object traveled? So first we're looking for A. So what equation do we have that has a VI, a VF, a delta t, and an A? When you look up at your 4 choices, hopefully it's like, oh, it's the one that we've been using before today. A equals VF minus VI over delta t. Again, you don't have to rearrange it because I was kind. 50 meters per second minus 0 meters per second. You have to rearrange it because you're solving for A and it's already alone. Divided by 10 seconds. 50 divided by 10 should be 5 meters per second divided by seconds, meters per second squared. We have found our acceleration. What is the distance traveled? So again, we now have A. We're looking for distance traveled. We know the VI, we know the delta t, we know the A, so we can use delta d is equal to VI delta t plus 1/2 A delta t squared. The VI is actually, it told us from rest, so the VI is 0. And if the VI is 0, then this whole first term, the VI times the delta t, goes to 0, because anything multiplied by 0 is going to be 0. So this becomes 1/2 5 meters per second squared times 10 seconds squared. 10 squared is 100. 100 times 5 is 500. Half of 500 is 250. Meters per second squared times seconds squared should give us meters, which is a good thing because that's what distance is measured in. Okay? Number 3, calculate the stopping distance of a car going 4 meters per second when the driver applies the brakes to slow down to a stop at a rate of 10 meters per second squared. Okay, so going initially 4 meters per second. So VI is 4 meters per second. Slows down to a stop. VF is 0. And it says slows down at a rate of negative, simply meaning in the opposite direction of motion, negative 10 meters per second squared. Calculate the stopping distance. Delta D equals. What equation then do you know that has a VI, a VF, an A, and a delta D? So you go up here, we have a delta D, a VI, and an A, but no VF. And we don't know the delta T. We don't know the VF, we don't know the delta T. We don't know the delta T, but we could find it if we needed to. But here we have VF, VI, A. We could get our delta D in one step. So it's going to be VF squared equals VI squared plus 2A delta D. You're looking for delta D, so you have to rearrange before filling your numbers in. Okay, so it'll be VF squared minus VI squared equals 2A delta D. So then delta D will equal VF squared minus VI squared over 2A. VF is 0, so 0 meters per second squared. So this is just going to go minus, this is 4 meters per second, and it gets squared, over 2 times negative 10. Delta D equals 4 squared is 16. 16 divided by 20, and they're both going to be negative. This will be 0.8 meters squared per second squared over meters per second squared, right? So this will be meters squared per second squared when you square it. And on the bottom is meters per second squared. And remember, dividing by a fraction is like flipping and multiplying. So flip second squared over meters. Second squareds cancel, 1 meter cancels. You are left with a meter, which is a wonderful thing because that's what distance and displacement should be measured in.